Good evening all. Today we will be taking the summary tutorials for Introductory Organic Chemistry 2 course. I'm going to share the slides now. Hope the slides are visible. Welcome to summary lecture of the NPTEL PMRF tutorials of course Introductory Organic Chemistry 2 by Professor Harida Chakravarti and Neeraja Deshaputre. Myself Anisha Suresh, PMRF TFO this course from IIT Bombay. So here we will be just briefing the summary of lectures that were discussed in the previous 8 weeks, followed by we will be discussing one or two questions from each weeks. So coming to the summary of week 1. So in week 1, the topics that were discussed were essentials of NMR spectroscopy and electrophilic aromatic substitution. So in essentials of NMR spectroscopy, the topics chemical shift, shielding, frequency, regions of the proton NMR spectrum, regions of the 13C NMR spectrum, and the relation between the electronegativity and chemical shifts were discussed. Coming to electrophilic aromatic substitution reaction, so the Friedel-Crafts alkylation and acylation reactions were discussed, followed by Gattermann-Koch reaction. So these were the contents that were discussed in week 1. Now coming to the question based on week 1. So 1,3-dibromobutane has dash proton NMR signals. This is the first question. So for that, this is the hint. This is the structure for 1,3-dibromobutane. So now you can count the number of proton signals based on the structure and you can tell the answer.
Option D 4.
Yeah, option D is the right answer. So you can see 1, 2, 3, 4. So these are the 4 set of protons. So this will come as 1, 2, 3 and 4. So there are 4 proton NMR signals that will be coming in 1,3-dibromobutane's proton NMR. Now coming to the second question. When benzene and cyclopentene were mixed together in the presence of sulfuric acid, the expected product is. So this is benzene and cyclopentene. In the presence of sulfuric acid, it will be giving one of the 3 products A, B or C. So what is the right answer? This is a
Option C.
Option C is the right answer. So this is based on electrophilic aromatic substitution reaction. So in the presence of acid H2SO4, the cyclopentene will get protonated and a carbocation will be generated. So this is the electrophile. So this aromatic system, that is the benzene, it will go and attack the carbocation and it will generate this intermediate. Now for re-aromatization, the base that will be present in the medium, it can abstract the proton and then we will get the final product. Okay. So option C is the right answer. is an example of electrophilic aromatic substitution reaction. Clear?
Yes, ma'am.
Okay. Now coming to the summary of week 2. In week 2, the topics that were discussed were electrophilic aromatic substitution in phenol, then the effect of electron donating group on electrophilic aromatic substitution, then the effect of electron withdrawing group on electrophilic aromatic substitution, then we discussed nucleophilic aromatic substitution reaction, then a special topic Hammond's postulate were discussed, and essentials of IR spectroscopy was also discussed. Now coming to question number 3. The products of the following reaction are. So this is also an example of electrophilic aromatic substitution. Since the reagent it is given here, it is a Friedel-Crafts alkylation reaction. So what will be the major product? And what is the minor product?
Ma'am, option D.
Major product D and minor product B.
Yes.
Okay, let us see. So hint for this is the summary of directing and activating effects for different groups. So we have seen uh, when the electronic effect is donation by conjugation, and one example is NR2OR. These are very activating in nature and they direct ortho para only. Now coming to inductive effect, donation by inductive effect like alkyl groups, they are activating in nature. They are mostly ortho but para, mostly ortho and para, but in some cases meta is also seen. Now donation by conjugation and withdrawal by inductive effect. So some examples are fluorine, chlorine, bromine and iodine. They are deactivating in nature. So here the direction is ortho and mostly para. So the major product will be para compared to ortho. And coming to withdrawal by inductive effect like CF3, NR3 plus etc. They are deactivating in nature and they are mostly meta only. And withdrawal by conjugation like nitro group, cyano group, COR, SO3R etc. They are very deactivating in nature and they give meta product only. So this is the table that you can memorize for electrophilic aromatic substitution reaction directing and activating effects. So here we have seen our starting compound is having fluoro. So here the major product that we will be getting is para and the minor product will be ortho. So here you can see B is the para product and D is the ortho product. So this will be the answer. So we will see the mechanism. So this aryl chloride, it will get activated in the presence of AlCl3 by donation of this electron to aluminium. Then what will happen? This lone pairs, it will push the electrons like this. This double bond will shift here and this double bond will go and attack at this position, and this AlCl4 minus will leave, leading to the formation of this compound. And then for rearomatization reaction, this proton will be abstracted and this positive charge will be neutralized, giving the product. When the attack is taking place from this direction, excuse me, Cl AlCl3 minus plus. So if the attack is taking place in this fashion, so it will give the ortho product. So this is the minor product and this is the major product. Since it is coordinating with aluminium chloride, aluminium, So we have to write it in this fashion. Okay, is this clear?
Yes, ma'am.
Okay. So here the major product will be the para one, that is B, and the minor product is D. So option B will be the right answer. Now coming to the next question. For the sequence below, identify X, Y, and Z. So here we are having this compound. In the presence of HNO3 and H2SO4, we are getting this product. So here X is given. So HNO3 and H2SO4, what reaction it will be doing?
Nitration.
So it will be doing nitration and X will be NO2, right? And then this under treatment with Y. So this nitro group is converted into amine. So what is this? It is a reduction, right? Reduction. So what reagents can do reduction of nitro to amine?
Option B.
Option B. Option B is the right answer. So, like Y, it should be hydrogenation condition. So, under hydrogenation condition, nitro group will be converted into NH2. Then, this is said condition, NH2 is converted into Cn. So, for that, first this group NH2 should be converted into a better living group. Like for that we will do diazotization reaction. So this NH2 will be converted into N2 plus by treating with NaNO2 and HCl. Then if we treat with Cn, addition elimination reaction will take place and we will get this product. Okay, then further addition elimination reaction with this NHMe2, we will get this final product. So the right answer will be option B. So we can know using HNO3 and H2SO4 nitration reaction will be taking place. So this is the mechanism for nitration reaction. So nitric acid and sulfuric acid. So this nitric acid will get protonated, and once this oxygen is pushing this electrons here, water will leave and we will get the nitronium ion, which is the active species for this reaction. Then the benzene can go and attack on this nitronium ion and we will get this intermediate. This upon deprotonation, we will get the final product. So this is the mechanism for nitration reaction. And in the presence of H2PDC, this nitro group can be converted into amino group. And here diazotization reaction, first NH2 in the presence of NaNO2 and HCl, it will get converted into N2 plus, which is a good living group as the nitrogen will be getting removed. And then if we treat with CuCN, this N2 plus will be getting replaced by Cn. So this is the mechanism for the reaction that we have seen. So the right answer will be option B. Clear? Any doubts?
No, ma'am.
Okay. Now coming to the summary of week 3. So in week 3, the basics of carbonyl compounds were discussed and the addition reactions on carbonyl functional groups. We have discussed the Felkinan model and all in this week 3, followed by nucleophilic addition reaction and its stereochemistry. So this is the question that is based on the Felkinan model. So in the given reaction sequence, so we are having an aldehyde. So here there is a chiral center and we are treating it with MEMGBr, that is methyl grignard. So in the presence of that, X and Y are getting formed. So what is the major product X? That is the question. So A, B, C or D. So this we can see from this viewpoint. So here this H will be coming in our left hand side and CH3 will be coming in our right hand side when we are seeing in this direction, and pH will be coming in the same direction as that of carbonyl. So we can draw it like this. pH, H will be coming in our left hand side and CH3 is coming in our right hand side. Okay. So this will be the starting. So in Felkinand model, we have seen that the attack will take place from the less hindered direction. So the nucleophile will be coming and attacking from this side. So before that, we will see how the mechanism of Felkinand model is taking place. So this is the system. Okay. So there are four possibilities for attack of the nucleophile. It can attack from this direction, but it is close to the pH, so steric reaction, steric hindrance will be there. So for the attack of the nucleophile, it should follow the Bourgade units angle, that is 107 degree from the carbonyl. So once it is attacking from this side, since it is close to pH, it will be having steric hindrance. Here, since hydrogen is only in the path, so here it is having a unhindered approach. When we rotate it and when we are having this structure, that is the largest group should come perpendicular to that of the carbonyl. Our structure should be such that the largest group will be coming perpendicular to the carbonyl. So the largest group is pH, so it should come perpendicular to the carbonyl. So we will take such structure for considering the attack. So when we rotate this to this side and the pH is coming perpendicular to the carbonyl, so here if it is attacking, here also it is close to the pH and this side it is close to Me. So in both cases it will be having steric hindrance. So here this path is considered the best flight path for the attack, where there will be unhindered approach. So the nucleophile will attack from this direction. So we will get this compound. Okay. So this if we redraw to dash and wedge formula, we will be getting this compound. So in our case, we are having double bond O, H, hydrogen, CH3 and pH. So we will draw it in such a way that the hydrogen will be coming next to the plate of attack, so that there will be unhindered approach. So we can redraw it in such a fashion like double bond O, H, CH3, hydrogen and pH. So we are rotating it in this fashion. Okay. So now the methyl group, it will be coming and attacking from this side and we will get pH, CH3, H, CH3, OH, H. Now for converting it into the Fisher projection, so you have to draw in eclipsed fashion. This you have to draw in eclipsed fashion. So for that, you will rotate it in this direction. So the pH, CH3, hydrogen, OH, CH3, hydrogen will be coming in this, and you can see if we draw it in this fashion, pH and OH are like in one line, then both CH3s are coming in the same side and both hydrogen are coming in the same side. Okay, so the right answer will be, that is the major product will be option B. Clear? Okay, so the right answer is option B. Now coming to the summary of week 4. So in week 4, the carboxylic acid and its derivatives were discussed. So reactions of carboxylic acid and its derivatives. And briefly, the alcohols, ethers and epoxides were covered. And a special topic, even CB reaction, were discussed. So coming to problems based on week 4. So this is the question. Arrange the following molecules in the order of their decreasing boiling point. Okay, which will be having the least boiling point?
Aldehyde.
Aldehyde will be having the least boiling point. So this we can assign 3. Then alcohol and acid, if you are considering, which will be having the least boiling point?
Alcohol.
Alcohol. Yeah. And then acid. So the reason for that, so the option C will be the right answer. So for the reason for this difference in boiling point is a hydrogen bonding interactions. So in case of alcohols, it will be having this sort of hydrogen bonding interactions. And if you are considering the acids, so here it can form hydrogen bonded dimers. So that is why this is having higher boiling point, and this will be coming next. It is also having hydrogen bonding, so that will be coming next. Since in the case of aldehydes, there is no possibility for hydrogen bonding interactions, it is having the least boiling point. So the right option will be option C. Any doubts?
No, ma'am.
Okay, now coming to question number 7. The major product formed in the following reaction is. So here we are having an epoxide and it is treated with this thiophenol derivative, salt of thiophenol. So what will be the major product that is formed here?
Ma'am, option A.
Option A. Yeah. So here there can be two possibilities for attack of the thiophenol, but we will be getting one major product. So what is the reason behind that? We can see that. So here the thiophenol can attack from this side or from this side, opening the epoch side. So if it is attacking from this side, we will be getting this product. Okay, and if it is attacking from this side, so this thiophenol will attack from this side and this bond will open, we will get this product. So here we can draw the chair conformation for this decalin system, and here we can find that the alcohol will be coming in the alcohol and the SPH both are coming in the axial position, and once the lone pair on oxygen can attack in SN2 fashion, this thiophenol can again leave, giving back the starting material. Okay, but in this case, both the starting material, both the alcohol and the thiophenol, they are coming in equatorial position. Here both are coming in equatorial and here in axial. So here this sort of attack is possible, giving back the starting material, but since here both are coming in the equatorial side, here such attack is not possible, and this will be the major product. So this if we read, so this is the major product that will be forming. If we redraw this, we will be getting this where the alcohol will be beta and the thiophenol will be alpha. Since SN2 reaction is taking place, here the attack will be from alpha side and we will be getting this product. Clear? So when such questions are there, where there are possibilities for uh, two attacks, so it is better to draw the chair conformation and see. Okay, so this will be the right answer. Any doubts in this question?
No, ma'am.
Okay. Now coming to the next question. The major product of the following reaction is. So the alkene is treated with mercuric acetate and then reduced with NaBH4. So what will be the major product that is forming? So I will.
Option
Huh?
option D.
Yeah, we will see. So what is happening in the presence of mercuric acetate? So here, like iodinium ion is forming, so this alkene will form a three-membered cycle with mercuric acetate, leading to formation of this intermediate. Now the water will be attacking from the more substituted carbon. Okay, so water will be attacking from the more substituted carbon, so we will get this intermediate. Okay, and when we treat it with NaBH4, then this mercuric acetate will be replaced by hydrogen. So we will get the more substituted alcohol in this reaction. Clear? Now We are having ester as well. So what will happen? Here the more substituted alcohol will be forming, as well as this ester will get reduced. So we will get the answer like D that you have told. So the more substituted alcohol and the ester is getting reduced to alcohol. So option D will be the right answer. Clear?
Yes, ma'am.
Okay. Now coming to summary of the week 5. So in week 5, enols and enolates were discussed, followed by their molecular orbital picture and the reactions of enols and enolates. So this is the question. In the given reaction, identify the correct combination of their major products P and Q. So here we are having this ketone. It is treated with LDA and then treated with this benzaldehyde. That enolate that will be formed is treated with benzaldehyde. We will be getting a product P, and we are having this cyclopentanone. So it is treated with LDA and then it is quenched with benzaldehyde. So we will be getting a product Q. What is the major product P and Q? So here are the options. This is option A, B, C, and D. I think the concept of diastereoselectivity was not properly discussed. So let's discuss that first. So for diastereoselectivity in aldol reaction, uh, generally we are telling, see, but clearly not always. So here if we are having a cis enolate that is forming, then the aldol product that we will get is syn aldol. And if we are having a trans enolate, then we will get anti aldol product. So here the product that we will be getting will be based on the enolate that is getting generated. Clear? So in the first case, here we are having a tertiary butyl group. In the presence of LDA, it will generate a cis enolate. If we are giving numbering, this will come first, right? 1 and 2. And here 1 and here hydrogen will be 2. That is why it is cis enolate. Since oxygen will be given more preference, here it will be forming majorly cis enolate because it have to avoid this tertiary butyl and the methyl group coming into contact so as to avoid the sterics. So since this is a cis enolate, when it will be reacting with benzaldehyde, we will be getting syn aldol product. Clear? Hello? Is this clear?
Yes, ma'am.
Okay. So here, if we choose the group X next to the carbonyl group to be large, then we can be sure of getting just the cis enolate. So for example, the lithium enolate of this tertiary butyl ketone forms just as one geometrical isomer and reacts with aldols to give only the syn aldol product. So here, so as to avoid this contact of this tertiary butyl and the methyl groups, which will be bulkier. So for that, the cis-enolate will be forming, and that upon aldol reaction, we will be getting the syn-aldol product. And in this case, cyclopentanone, when we are treating with LDA, there is possibility for formation of only the trans-enolate. Okay. Since this is a cyclic system, it can form only the trans-enolate. So 1, 2. Here hydrogen. So 1. Sorry, this will be 1 and this will be 2. So these are trans. So here only the trans-enolate is getting formed, and when the trans-enolate it is undergoing reaction with this aldol reaction with this aldehyde, it will result in the formation of this anti-aldol product. So some enolates can only exist as trans enolates because they are derived from cyclic ketones. This enolate, for example, react with aldehydes to give only the anti-aldol product. Here aldehyde it is. Okay. This is clear. So this is the concept of diastereoselectivity in aldol reactions. Clear?
Yes, ma'am.
Okay. So in our case, here we will be getting cis-enolate. Because of that, we will be getting syn-aldol product. And in this case, we will be getting trans-enolate. And because of that, we will be getting Q as anti-aldol product. So the right answer will be this option. P is syn-aldol. Q is anti-aldol. Clear?
Yes, ma'am.
Okay. Now coming to question number 10. Phenol on reaction with formaldehyde and dimethylamine mainly gives what product? So what is this reaction? This is a electrophilic aromatic substitution reaction. So what will be the major product that we will be getting? So coming to the mechanism. So first, in the presence of dimethylamine and this formaldehyde as given the reagents, so what will be forming? So nucleophilic attack on the more electrophilic carbonyl group will take place. So this lone pairs on nitrogen can attack this carbonyl carbon and it will generate this species. So in the presence of, so this will undergo a proton transfer giving this compound, and in the presence of HCl, so this will get protonated, and when the lone pairs will fall, this water will get removed leading to formation of this imine salt. This is the active species. Okay. Now what will happen? This phenol will undergo an electrophilic aromatic substitution reaction. So this lone pairs will fall and this bond will go and attack on this carbon, neutralizing the positive charge on nitrogen, giving this intermediate. Now rearomatization reaction will take place by removal of this proton, giving this as the final product. Clear? What could be the reason for formation of ortho product as a major compared to that of para? Yeah, OH is electron releasing group. But in majority of the cases, we have seen para will be the major product, ortho will be the minor product. I hope there is some sort of hydrogen bonding interaction between this nitrogen and this OH hydrogen. Maybe because of that, this para will, ortho will be the major product compared to that of para. Like this. Yeah, intramolecular. Intramolecular would be more favored compared to that of intermolecular, right? So this sort of a hydrogen bonding might be there. Maybe because of that, yeah, within the molecule, intramolecular hydrogen bonding. Maybe because that is the reason why ortho product is major compared to that of the para. So here the major product that is formed is option A. Clear?
Yes, ma'am.
Okay. Now coming to summary of the week 6. So in week 6, active methylene group were discussed, followed by aldol and related reactions, and aldol reactions with specific enol equivalents were also discussed. So now coming to question number 11. In the reaction, the products X and Y are. So we are having one aldehyde here and a formaldehyde. It is treated with concentrated NaOH. We will get X plus Y. So we have to identify what is X and Y. So before that, what is this name reaction?
Cannizzaro reaction.
Yeah, this is Cannizzaro reaction. So what will be the major products X and Y?
Option A.
Option A will be the right answer. So here the NaOH will be first attacking on the most electrophilic carbonyl. So when we compare this aldehyde and this aldehyde, formaldehyde will be more electrophilic because this is electron releasing group by conjugation. So this will be less electrophilic compared to that of this. Okay. So that is the reason why first the NaOH will be attacking on the formaldehyde. So NaOH will attack on the formaldehyde, leading to formation of this anion. So again, one molecule of base can abstract the proton, leading to formation of this dianion. Now what will happen? When this O minus will fall, the hydride will be removed and it will add on to the aldehyde, the benzaldehyde that is present, and we will be getting this alcohol and this carboxylate. Okay, so this will coordinate with Na plus to give this salt. So this will be the final product that is formed. Clear?
Yes, ma'am.
Okay. So this is Cannizzaro reaction. When there are no alpha hydrogens present, Cannizzaro reaction will be taking place. Option A is the right answer. Now coming to question number 12. Consider the following reaction. Which among the following is a major product? So we are having this methyl substituted cyclohexanol and it is treated with LDA, and finally it will undergo aldol condensation reaction with this acetaldehyde, giving a product. So you have to identify that product. A. Option A is the right answer. So LDA, since it is a bulky base, so here there are 3 alpha hydrogens. So since LDA is a bulky base, it can abstract the proton from this side, okay, leading to formation of the kinetic enolate. So LDA, it will be abstracting the proton from this side. So this is the structure for lithium diisopropyl amide. So this will be abstracting the proton from this side, leading to formation of this enolate. And then this enolate can attack on the acetaldehyde, leading to formation of this aldol product. Okay. Then again this enolate will be forming, and it will undergo an even CB reaction, leading to formation of the final product. Okay. So this even CB elimination is taking place under heating conditions. Fine.
Yes, ma'am.
Okay. Now coming to, sorry. So here option A is the right answer. Now coming to the summary of week 7. So in week 7, the conjugate addition reactions, that is 1,2 addition and 1,4 addition reactions were discussed, and how the kinetic and thermodynamic products are formed in conjugate addition were discussed, and the difference between hard and soft nucleophiles were discussed. Then we discussed enol and enolate alkylation reaction and the regioselectivity of that alkylation reaction. Finally, acylation of enol or enolates and the related name reactions were discussed. Okay. So here, what will be the product B in the reaction? So a nitroalkane in the presence of a base react with aldehyde or ketone, leading to formation of this beta nitroalcohol, and it will undergo a dehydration reaction, that is removal of water, leading to formation of B. So what will be the product that is formed here? Is it a alpha nitroalcohol, alpha nitroketone, nitroalkene, or a beta amino alcohol? And before that, this is a name reaction. The first step is a name reaction. What is that name reaction?
Henry reaction.
Yeah, this is Henry reaction. So in Henry reaction, nitroalkane reacts with ketone or aldehyde, leading to formation of a beta nitroalcohol. Now this is getting removed. It is undergoing a dehydration reaction, leading to formation of what will be the product that is formed here? NO.
Nitroalkane.
Yeah, nitroalkene is getting formed. So the final product is nitroalkene. So this is the mechanism for Henry reaction. The base will be abstracting this alpha proton, alpha to that of the nitro group, which will be more acidic, leading to formation of this intermediate. And this will go and attack on the ketone or aldehyde, leading to formation of this nitro hy- um, beta nitro alcohol, alpha beta. Okay, and then it will undergo removal of water, leading to formation of this product, and it is known as nitroalkene. Clear?
Yes, ma'am.
Okay. So the final product that is formed here is nitroalkene. Now coming to question number 14. Which of the following is the reactant precursor for the given product? So this is the product that we are getting, and we have to identify two reactants from the given four options that will be giving this final product.
Option B.
Yeah, 1 and 2. So this will be the starting materials, this ester and this ester. Okay, so first in the presence of a base, an enolate will be generated here, and that will go and attack this carbonyl, and then this ester will be leading to formation of this product. Clear? This will be the mechanism. Here this proton will be abstracted, leading to formation of this enolate, and this enolate will go and attack this carbonyl carbon, leading to formation of this tetrahedral intermediate, and this tetrahedral intermediate will collapse, leading to formation of this final product. Okay, what is this name reaction?
Claisen ester condensation.
Yeah, this is Claisen ester condensation. So the right option is 1 and 2 will be combining to give this product. So option D is the right answer. Clear?
Yes, ma'am.
Okay. And in week 8, we were discussing different rearrangement reactions and some of the important name reactions. So here, this is question number 15. So which is the final rearrangement product of the reaction given below? So what is this name reaction? By seeing the starting material and the reagent, can you suggest what is the name reaction?
Pinacol rearrangement.
Yeah, this is pinacol-pinacolone rearrangement. So what is the product that will be formed here? A, B, C, D. Try to work out the
Option B.
mechanism. Huh?
Option B.
No. Try to draw the conformation and see. Option B is the right answer. So we will see the mechanism. So this is the starting material. So this could be drawn in this fashion, right? Alcohols are coming in beta position. So this is coming above beta. This is also coming above beta. Now the axial OH will get protonated and it will be removed, leading to formation of the carbocation here. Now what will happen when this lone pair on oxygen will be falling down? This methyl group will migrate to this carbocation, neutralizing the carbocation, and we will be getting this as a final product. Okay. So when there is cyclohexane system or decalin systems, try to draw the chair conformations for predicting the products. Okay.
Yes, ma'am.
Okay. So here the right answer is option B. That is the cyclohexanone product. Now coming to the last question of this tutorial. So which lactam would be the main product of the following rearrangement of an oxime when the cis trans isomerization of the oxime is retarded? That is, retarded means it is stopped or decreased. So what is this name reaction or the rearrangement?
Backman rearrangement.
Yeah, this is Dickman rearrangement. So what will be the major product that is forming here? No, the answer will be A. So you try to work out the mechanism first, then it will be clear. Since this is the oxime, so the group that is trans to the oxime will be migrating. Always the group that will be trans to the oxime will be migrating in the case of Beckmann rearrangement. So that is the migratory aptitude in case of Beckmann rearrangement. So this group will be migrating to this side and this OH will be getting removed. Okay, we will see the mechanism. So in the presence of PCl5, so this will coordinate with this alcohol and HCl will be removing, leading to formation of this OPCl4 bond, and then the group that is trans to the oxime will be migrating. So this group will be migrating, removing POCl3 and Cl minus, and this seven membered group will be system will be forming. Now here a positive charge is there. Since this group is migrating from here, a positive charge will be generated here, so that is present here. Then the water will be coming and attacking here, leading to formation of this, and this upon cis trans isomerization will lead to formation of this lactam. Okay, so here the methyl group will be present, one carbon apart from the lactam amide. Clear? So try to work out the mechanism for predicting the product. So option A will be the right answer. Any doubts?
No, ma'am.
Okay, so this was all for today's lecture. So here I have just briefly discussed all the topics that we discussed. I didn't discuss any mechanisms, and we were discussing few questions from each part. So try to work out the mechanism before going for the exams. If you are working out problems, doing the mechanisms, then it will be easy for you to predict the products. So all the best for your exams. Thank you.
Thank you.
Thank you, madam.
Thank you.